Let's take a look at a couple of application problems using the law of cosines. So here we have an example that says two airplanes leave an airport at the same time on different runways. One flies directly north at 400 miles per hour. The other airplane flies at a bearing of north 75 degrees east at 350 miles per hour. How far apart will the planes be after 2 hours? So to help us with this, I would suggest that we first and foremost sketch a picture. So if we're talking about one airplane is flying directly north, I would say, okay, well, let's have the airplane start here. Flying north means that they're heading up. Notice the directions asking how far will the airplanes be apart after 2 hours? The directions are saying that the plane is flying 400 miles per hour. So if that's only happening every 1 hour, I actually have to double that value to find where the plane is at the 2 hour mark. So 400 times 2 tells us that I really want 800 miles going up. It also says that the other airplane flies at a bearing of north 75 degrees east. So once again, if this dot here started the airport where the planes were taking off, I want that to be the origin if I'm thinking about my bearing. And so northeast tells us that we are heading over here up and to the right. Okay, once again, this distance of the plane is 350 miles per hour, but we are talking about a 2 hour time span. So if I double 350, that tells me that over here we'll have 700 miles. Because 75 degrees is a part of the bearing, and I always want the angle to be formed with the north-south line, that means this angle right here is 75 degrees. So if the question's asking how far apart will the airplanes be after those 2 hours, I want to figure out what this side is. I'm going to call it X. And so this is why we are using the law of cosines, because notice that what I've drawn is a side angle side scenario. And side angle side means we're using law of cosines. Remember, if I want to find the side across from the only angle that's given, that side is going to have to be isolated by itself using our law of cosines formula. So x squared is going to equal, I'm going to take the two other sides, square them, add them together, and then subtract 2 times the product of those two sides as well as the cosine of the angle that is given, so 75 degrees. Once again, 2 different ways for you to go about solving for x. You can go ahead and type everything into the calculator that we have on the right-hand side of this equation, being very careful with order of operations. I'm going to go ahead and do that. So I'm going to leave it as x squared. When I type all of that in, I do not get a nice clean number. So what I'm going to do is I'm going to round to 4 decimal places. Because like I have mentioned in the previous video from yesterday, this is not going to be our final answer. I want to try to get as exact as possible. So the most, well, not the most, but a good number of decimals is going to help us get a more accurate answer. So I'm just going to go 4 decimal places. I still don't have x. I have to take the square root then in order to get x by itself. The other way that you could have done this is you could have done the square root and then typed everything on the right-hand side into the calculator, just being very careful with order of operations as you're doing that. Since the I guess the directions didn't tell us what they wanted us to round to. Let's go ahead and round just then to the nearest tenth of a mile. So typing all of that in and rounding to the nearest tenth, hopefully we are all okay with an answer of 916.6 miles. And since x is what we were trying to find, that's the distance the airplanes are apart, that is my final answer. Looking at this second example, using the picture, it says if you were on island A, on what bearing should you navigate to go to island C? Island A, right here at the bottom left, island C up at the top. They've given us distances for all of the miles between the islands. So notice that we are in a side scenario. So we have to use the law of cosines to help us out. The directions from yesterday, we have to find the angle that is across from the biggest side. Notice 7 is the longest side between 5, 6, and 7. That means we have to figure out what angle A is. So we're going to set that up using the law of cosines. So 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of angle A. I'm going to start trying to isolate that cosine of A by itself. You can square those numbers. Notice that I am going to be moving the 5 squared and the 6 squared over to the other side by subtracting those numbers. Like I said, you could square those right away. We still have this negative 2 times 5 times 6 times the cosine of A. You can go ahead and multiply those three numbers together if you want. Whatever that product is, which it's really 60, I'm going to divide, negative 60. I'm going to divide all of this by negative 60. That will get me the cosine of A by itself. I can very carefully type all of this in. So 49 minus 25 minus 36. Get that number and then divide it by negative 60. And then make sure we're taking the inverse cosine of that quotient. And when we do all of that, the inverse cosine of, once again, all of this will get us what the measure of angle A is. And so the measure of angle A ends up being 78 degrees when we round to the nearest whole number. That's not our final answer. It's asking for a bearing. And if I want the bearing to go from island A to island C, that means that this vertex right here has to be the origin if we're thinking about our north, south, east, west, or our x and y axis. So the value that I just got was 78. Notice that that is not the angle that is going to be a part of my final answer because I always want the angle that is formed with the north-south line. So I have to figure out what this angle is. And remember, it's going to be the complement of the 78 degrees. So when I take 90 minus 78, I'll get the angle that I want. So we're dealing with a 12-degree angle. And notice that from A to C, we are heading up. So we are going to have a bearing that is north. We just discovered that we are dealing with 12 degrees. And because island C, you had to move up and to the right, well, moving to the right means that we are heading in a direction of east. So this is our bearing, north 12 degrees east.